So dear friends, as you can see on the screen, we are going to study today the one more technique of biostatistics or statistical tool, which is called as calculation of a standard deviation. Once again, I welcome you. Very good morning, and I hope that now I am perfectly audible to you. So as far as concerned with this particular practical, which is entitled here as calculation of a standard deviation. So what is exactly standard deviation? This part you have to first of all understood. If you remember in previous practical, that is practical number 1 of a biostatistics, you came across with a concept called as a central tendency. That is nothing but a finding the central figure of any biological or any statistical data if it is provided to you. From that we can gather a central idea or central information which is in a numerical state. Basically that is called as a mean, or it may be the median, or it may be the mode. But what happens sometimes, these particular values of the three tendencies, they are not matching with each other. They may be sometimes show certain variations. If mean is coming for the 14 values, say for example 35, mode if it is coming 33, or it may be the median value it is around 32, so that may be a kind of a differences in between all these three values, whereas it should be exactly very close to each other. But this particular error, this particular difference from the central figure has to be get standardized, and that method of a standardization is referred as standard deviation. As you can see on the screen, there is a formula it is given to you, but don't bother about that one. Formula, how this formula has to be get remember in your mind, that is the main actual skill. And in fact sometimes this formula it is denoted by some other ways also. So at present I am trying to make this practical very simple and easy. First of all, try to understand what is provided to you for today's practical. So this information it is given to you, certain formula is given to you. I am going to modify this formula later on. Toward the end of this practical, I will provide you that particular formula, and a data has been provided. Now just look at the data what is given to you. Following is the data representing the number of fruits of 16 strawberry plants. Using this data, calculate the standard deviation. Now data is very simple. If you look here, there were total 16 observations made for the strawberry plant, and here what happens, number of fruits they were counted, or they were studied for per plant. So say for example plant number 1, it is carrying around 24 strawberry are present on that particular climber. On the plant number 2, if you go, there are 28. On plant number 3 there are 23. On plant number 4, 21, and so on. It goes ahead with 16 till the 16th plant, total 23 strawberries were present. So what we can understood from this one, if you want to make any conclusion here, if you go for the process that is called as a standard is sorry, I'm extremely sorry, mean, median and mode. So you will get certain figure, that is the average. Perhaps that average figure it may be in the fractions also, but it shows all these three figures it may be varied. So when data goes ahead, the data becomes little bit a bigger one. At that time, to standardize the error, standardize the deviation, we have to go for the some modifications in the process, because the individual observation whatever may be is there, that is a 24 number of the strawberries per plant, if it is considered along with the average, suppose 28. So if that 28 and 24, it makes a difference of a 4 strawberry plants. At same time there may be a 21 also. If it is a average value, if it is coming at 24, 21 is quite lesser. So 21 with reference to 28, or 24 with reference to 28. So all this creates a deviations, and to make standardization of this particular data, we have to go ahead with a procedure that is called as a determination of a standard deviation. Similarly, one more table has been given, but as per and this table it consists of certain information related with the number of flowers per flowering twig, or simply called as the inflorescence of a gulmohar plant. So that number of flowers data has been provided to you for almost 15, 20, 25, 30 plants. Almost for 30 plants this data has been given to you. So today, unlike like to the last practical, I will not discuss with any one of the data which is given to you. Instead, I'll give you a simple idea how to how to determine the standard deviation, and for that purpose you just focus on what technique and what simple procedure I am going to tell you, because more often in biostatistics students get confused about how that formula has to be get remember, or how if any figure or any denoted value, if it is kept at a wrong place, it may be definitely get your result total wrong. So don't worry about that one. We are going to look for that actual fact, how to determine the standard deviation, and I am trying to make it this particular concept very easy. So dear students, have a look on the screen now. As I had said that we are going to determine standard deviation. Deviation name itself indicates it's a difference, and standard difference from the central value we are going to measure, that is called standard deviation. So as far as concerned with this particular interesting fact, we'll deal with a simple example. Say for example, you are total 5 friends are there, and you 5 friends are having a tendency to maintain your refrigerator with a unique number of vegetables or fruits. In fact, now if say for example, if you are putting the vegetables, but what happens, 5 different friends, they are having different likings perhaps of the vegetables, or some similarities may be also there. And in fact, the tendency of keeping the stock of vegetables in free refrigerator, it may be also varied. Say for example, if you are the first one, and if you keep in your fridge 2 vegetables suppose per week, or second friend is possessing, or it is keeping 3 vegetables, third one it is having fourth, so next one is having 7, and another one is a 9. So in short, what total vegetables among the 5 these people, if it is measured, what is noticed over there? 2 plus 3 plus 4 plus 7 plus 9. And from this, what we are we are trying to make a conclusion. We are trying to find out what is a general tendency of these 5 people, that means average number of vegetables in their refrigerator. We are trying to find it out. Now in our present case, the strawberry plant, it is given that is around either 16 or 20 plants are there, and per plant how many strawberries are there. So this was actually part of a central tendency, but from individual to individual, how that average figure or how that mean figure is varied, that is a part of our interest. That means very first important step is that you should know what is a central tendency or what is a central figure. So as you know, to determine the central tendency or central figure, what we had to go ahead, we had to find it out first of all, the mean value, and all of you know how mean it is get calculated. This is denoted by letter x bar. So x bar, it is nothing but a summation of all those observed values actually. Now here it is 2, here it is 3, here is 4, then so on that number it may be goes ahead. So if you go for the calculation of a mean value for that individual observation, in your case that table it is given, from that table, all from each cell of the table, all these figures has to be get first of all made a total and divided by that total number of observations. Now here 5 are the actual individuals which are having these many numbers of the vegetables individually, 2, 3, 4, 7, 9. So all together that value, if it is measured, okay, that total value 2 plus 3, that is 5 plus 4, that is 9 plus 7, that is 16 plus 9, that is 25. 25 upon 5, that indicates the 5 is nothing but a calculated mean value, or is simply called as a x bar value. So dear students, what we can conclude from this one, among these 5 friends, 5 observations, it is observed that generally, in general, okay, total number of vegetables, average number of vegetables, okay, they are 5. Now answer is very interesting. It looks very interesting that 5 vegetables are generally there in a refrigerator, but is it a fact, reality? No, never. Because if you look for the very first you see that a individual, in his or her fridge there are only 2 vegetables in comparison with this mean observation. Similarly, in case of a last person, in his refrigerator there are 9 vegetables as compared to the average 5. That means it is exceed by means of a figure 4. In this particular case, they are less than the figure 3. So everywhere you will find it out that the values, they are deviating from the mean, and therefore we are going to standardize this particular difference, and this is the very first step toward the determination of a standard deviation. The mean value first of all calculate, for by that you have to go for this getting the difference. What just now I had told you that this particular x bar is nothing but a average value, that is nothing but a mean. How that mean is deviated, how that mean is differ from individual observation. Okay, first observation, second observation, third, fourth, fifth, and so on. So these are the differences. Say for example, very first difference, it is calculated x minus x bar, it is nothing but a -3. Next one, it is -2, -1, 2, and 4. Means value there lies in the positivity as well as the negative range over there, and therefore this data which is observed over here, this particular point of a observation, here it is a mean value, and you can call it as an individual observation or simply called as a each data point. So these differences are mainly calculated by means of a simple process that is called a subtraction process of a mean value from each data point, or is simply called as an individual observation. And of course after this very simple way, the value which is maximum, it has to be get maximized, or which is lowest or -1, it may be get converted by means of a getting its square. So next step is to get a square of each difference, and here -3 or is simply called as a -3, it get converted into the 9. Of course -2 it becomes 4, -1 becomes 1, and of course 2 becomes 4, and 4 becomes maximum 16. So in this way the third step is getting a square difference. Of course this is not an end. Next part is very important. You have to go for the calculation of a mean square value. In earlier case, what we did first, we first of all took the mean value of individual observation or data set observations or data observations. Now what we are doing, we are trying to get a difference square. Okay, difference of what? That is nothing but the calculated mean values along with a individual observations. That difference is get squared, and that square values you can call it as a mean we are going to calculate. Now all of you know 9 plus 4 plus 1 plus 4 plus 16. Okay, and to get a mean, what we have to do, you have to divide it by means of total number of observations. So how many observations are there? There are 5 observations. So you can just calculate it. What is that figure? This figure comes around 6.8. Now dear students, you just have a look for this particular figure 6.8. So this 6.8 figure is the actual square value which is observed, and this value, it will help us to give you actual deviation from individual observation, and to perform to get that particular figure of a actual difference. Okay, closest difference, what we can do, we can undergo for having a square root value for this particular, is that a figure that is 6.8 what is observed. This is nothing but a difference or deviation between mean value and your individual observation square. So under root, okay, you can take the square root value of 6.8, that is nothing but the figure giving you a value called as standard deviation, and in present case it is 2.6. I hope that up to this one there is no such doubt. What we had did, that particular step we have to remember, and what are the procedures, what we had done, that is very important. So look at the screen. 2.6, this is the value what we have calculated. Very first step which was there, during which we made a conclusion. Yes, among the 5 friends, their refrigerator that possesses the 5 vegetables. So that was our main conclusion. But it was observed that the first person's refrigerator is possessing only 2 vegetables, which is totally differ from the 5 vegetables. So 2 and 5, there is a great difference of a 3. Okay, whereas the 5th person was possessing the 9 vegetables, that 9 along with this mean value of a generalized figure, that is also a great difference, that is of a 4. But where we get this particular standard deviation 2.6, if you notice the first observation or first individual where it is possessing 2, so 2 and 2.6, it is not a biggest difference. So such type of a differences you have to calculate you have to measure it by standard deviation process. Similarly, at the nine vegetables, they were the part of a fifth individual or fifth person or fifth friend. That means 5 and sorry, 9 it was the actual difference. So from 9, if you look for that particular deviation 2.6, so 9 minus 2.6, that will be almost a closest figure over there toward the somewhat 6.4 or something like that one, which is very close again toward the mean value. So in this way, what we can make, what standard deviation provide us, that standard deviation provide us the closest difference, and in fact it gives an idea about how that particular data, how that particular values, they lies in a particular, is that a distributional pattern. So if you look for the if you put all these figures in a graphical presentation, that means individual observation, first individual is possessing how many vegetables, second, third, fourth, fifth. Okay, from that central tendency, if you measure, it was nothing but the 5. So this is what the figure 5, that is a mean value. But if you look this particular portion, okay, the distal portion over here, that gives rise to almost 2/3 of the data. Out of that particular 5, 2/3 data, that is around 2.6, it lies there here in this particular portion, that is called as a standard deviation. So about 2/3 of a data fall within the standard deviation of the mean. That indicates it's a kind of a positive type of a distribution, positive distribution. Sometimes this particular peak, it may be uneven, it may be like this one, or it may be very sharp up to this one, and it is not even distribution also. So even or uneven distribution, they may be up or different, use that a point of a discussion also. So as far as concerned with this particular information, what we can conclude now, just now I had told you the average number of vegetables present among this group of 5 people, that is 5 vegetables average value. But in true sense, the first one was possessing 2 and fifth one was possessing 9. So that means 2 and 5, they are far away from each other, or 9 and 5, that is also far away from each other. But if you get that particular standard deviation, what it indicates, this particular mean value 5 plus 2.4, if it is measured 2.4, okay, sorry, 5 minus 2.6, that is the standard deviation, that gives rise to toward the lowest figure, that is 2.4, it may becomes over here. That 2.4, it is nothing but a value approximately close to the 2. Okay, whereas if you add toward the positive, use that a increase, 5 plus 5 is the mean value, and extremely use that a highest figure which was noticed in these individual observations, that was 9. So 5 plus 2.6, if it is added over there, that becomes almost 7.6, or it is very close to the 8. So that 8 is comparative to 9, it is little bit closest figure. So in this way, these extremities, lowest and highest, they are bound together by means of a common standard difference, and this common standard difference is called as standard deviation. Dear friends, concept is very simple. You have to simply go ahead with a particular formula, and this, how that formula it may be get designed, answer is very simple. But prior to that, you have to remember all these 5 steps. First of all, calculate the mean, then subtract the mean from the each data point, that is data point is nothing but individual observation, then square each difference, followed by that calculate the mean of a square differences and take the square root of that particular difference value. And if you follow all these things, ultimately your standard deviation it is get calculated. Okay, if you follow all these things, ultimately it is nothing but procedure what you have followed, that is giving rise to a standard deviation. But to standardize that formula, what is given, that sigma is equal to under root of summation of differences between the mean value and individual data set. So this is the actual process. Okay, subtract the mean from each data point, that means x minus x bar. Okay, after that what you do, you get a square of that particular difference of a square means x minus x, this is the summation of a x minus x bar square value, that is nothing but the step number, we can say that this particular 4, and after that this individual, of course n, it is the very important figure, that is how many observations are there, that is used here to divide this value, and of course it is a under root. Dear students, you have to remember here a sigma, it indicates the standard deviation. This sign, it is nothing but the summation sign for the each observations difference. Of course x, that is nothing but a data point, or simply called as a individual observation, and x bar, it indicates a mean value, and of course n is nothing but the number of data points, or simply called as total number of observations. This is what a simple way. But sometimes what happens, if there is a big population over there, and at that time instead of this particular figure n, okay, little bit modification it is made, and that modification is nothing but a sigma, okay, or standard deviation is equal to under root of summation of x minus x bar square upon, there is a slight difference, n minus 1. So this difference you have to remember. Okay, so generally whatever may be data it is provided to you, it has to be get processed by means of this one. But at higher level of data and nature of the use that samples, n minus 1 it may be also applied. I hope that you have understood this particular concept in a little bit precise way. Whatever may be information provided to you on the Google Classroom, that particular data, there are two tables provided to you. You use that tables for calculation purpose, and of course after that we can